This video deals with some of the problems that people have drawing mechanisms or reading how mechanisms are drawn. So what I'm going to do is look at the reaction of an ester. So draw the ester, and I'm going to react it initially as drawn with methanol. Okay, so I'm drawing in explicitly the CH3. That could be left just as a straight line as well, because the hydrogens would be implied. Put on the lone pairs and the oxygen, and remember, anytime you have on oxygen, you've got to think about the fact that it's got lone pairs. Now if it's going to react, I won't go into why this, but it will always react to the carbon of the carbonyl as I've shown. And one of the common ways of drawing this is as I've drawn just there. The two electrons of the lone pair attacking in at the carbon of the carbonyl, creating a bond between that carbon and the oxygen. The two electrons of the carbon-oxygen double bond moving up onto the oxygen. So that's one common method would be used, or one common way that will be shown, that arrow going into that carbon of the carbonyl and up. There is another way of looking at it, and another way it can be represented, and that is equally correct but slightly different. So I've redrawn the exact same starting material, and in this case what I'm doing is I'm drawing in a dotted line. And this is common. What I'm indicating is these two atoms are the ones that are going to be connected by the new bond. And in this case we push the lone pair electrons to the space between those two atoms. It's the exact same process, it's just a slightly different way of looking at it. Again, that carbon of the carbonyl can't have 5 bonds, so the two electrons of the carbon-oxygen double bond move up onto the oxygen. And in any mechanism it's important initially to draw the structure of what you get, and in both cases we're going to get the same structure, so I'm going to show one structure here, but get the connections right first. Okay, so get the connections right first, where you should have a single bond, put in a single bond, etc., and worry about the charges later. Now in any reaction where you start with a neutral species, and we started with an ester and an alcohol, that means the overall charge on the product has to be neutral as well. In this case we end up with a positive charge on the oxygen that came from the alcohol, because it now has 3 bonds. We end up with a negative charge on the oxygen that came from the carbonyl, because it has 1 bond. So what I'll do is I'll draw 2 other mechanisms involving the same ester and a similar type of attack, but in using slightly different starting materials. So if I redraw the ester, and this mechanism is going to involve the attack of hydroxide, OH-, and again the 2 electrons represented by the negative charge and the OH- can attack in at the carbon of the carbonyl, and that's represented by this arrow. Again, the 2 electrons of the carbonyl, as always, will move up onto the oxygen. Now again, you can draw this in the other method as well, by indicating the bond that's going to be created by putting in a dotted line, and sometimes that helps to visualize exactly what's going on. So again, if I redraw it, put in the negative charge, and now connect the carbon of the carbonyl and the oxygen of the hydroxide by a dotted line, it gives me some indication of the bond I'm creating. And what I need to do to create that bond is to push 2 electrons into that space, because all a bond is a sharing of 2 electrons. So I push the electrons into the space, being very careful about where the arrow starts and finishes, and again the 2 electrons of the carbonyl up onto the oxygen. Again, these are just 2 different ways of visualizing the same reaction, so the product is going to be the same in each case. So I'll draw the structure first. Again, get your connections right, worry about the charges, etc. later. In terms of charges, if you start, as we did in this case, with 1 neutral species and 1 negatively charged species, then the products overall have to be negatively charged. And you can see we've pushed electrons up onto the carbon of the carbonyl, onto the oxygen of the carbonyl. That oxygen is now negatively charged. The OH- lost its electron, or lost the negative charge. It was used to create a bond, so it's neutral now. The last case, I'm going to involve a positively charged species reacting with a neutral species, and again I'm going to look at it in the 2 different ways you can represent the reaction. Again, so I'm going to react methanol with the ester again, but in this case the ester has already been protonated. Not going to worry about how that process happens, but just that the ester carbonyl has been protonated means it has a positive charge. Again, the oxygen lone pair attacks in at the carbon of the carbonyl. It's creating that bond between the oxygen and the carbon. The 2 electrons of the double bond go up onto the oxygen, and that's going to have the effect of neutralizing that positive charge. Again, I can represent it in another way by redrawing the protonated ester, okay, and redrawing my alcohol. And in this case, again, what I'm going to do is represent the bond that's created by a dotted line. I need to put the positive charge on the oxygen of the ester because it's been protonated. That oxygen has 3 bonds, which will always mean it has a positive charge. So I'll put in the dotted line indicating the bond that's created, and then we'll move the electrons into that space. So push the electrons in, be careful where the arrow starts, be careful where the arrow finishes. It should start at the lone pair, it should finish at the middle of the bond if you're doing it by this method. 2 electrons of the carbonyl double bond move up onto the oxygen, and that's going to have the effect of neutralizing the positive charge. We've pushed electrons into a space that was positively charged. Overall it's going to be neutral there now. But our starting materials, one was positively charged, one was neutral. The overall charge on our product is going to have to be positively charged in this case. But redraw the structure first. Worry about where the charge resides after that. So if you look at it, 1 oxygen has 3 bonds. It's the one that came from the alcohol originally, so overall that's going to be positively charged. It's a good idea to get used to tracking the structure and tracking the charge. If you start overall neutral, product is overall neutral. If you start overall negative, product is negative. If you start overall positive, product is positive.